Hey guys, I just want to go over the answers to this solving quadratics review because this is it's a pretty hard chapter, and I kind of want to go along with my thought process along the way as well. So we want to determine the best method, so the easiest method, because truth be told, everything could be solved by completing the square, but sometimes that turns into an enormous mess. Everything can be solved by the quadratic formula, but sometimes that just takes way too long. So you want to pick out really the best tool in your toolbox for certain things. So the first thing here, number one, the best way to solve this is square rooting. Okay, so the square root method is best used when there's no linear term. So see over here we have an x, this one we do not. So the reason why, so the fact that there's not an x, okay, only having an x squared, all right, means that I can get the x squared by itself, okay? And then when the x squared is by itself, I can take the square root of both sides. So I can get x is equal to plus or minus the square root of 9. So I get x equals the positive square root of 9, and x equals the negative square root of 9. So also remember with quadratics, most of the time you're going to be getting two answers, okay? Number two, I have a linear term, so I definitely can't solve this by just square rooting. I could try factoring, so it'd be factorable. So I have 9 times negative 4 is negative 36. So anything that multiply to negative 36 and add to 4. So if I do like 9 and negative 5, that's negative 45. If I do 8 and negative 4, right, I'm just doing things that add to 4. So this gives me 45, negative 45, and this gives me negative 32. Okay, neither of those are negative 36, so this doesn't appear to be easy to factor. I have a 9 in the front, so I don't want to do completing the square. This might be a quadratic formula situation. Okay, so remember the solution to the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and that's where we get our two answers. We still have the plus or minus in there. So here, my a is 9, my b is 4, my c is negative 4. So x equals the negative of 4 plus or minus the square root. B is 4, so b squared minus 4 times 9 times c all over 2 times 9. So we get x equals negative 4 plus or minus the square root. This is going to be 16 plus, because I have two negatives there. So 4 times 4 is 16 times 9 is 144 all over 18. So 144 plus 16, let's do this off to the side. 16 plus 144. That's going to be the square root of 160. 160 is 16 times 10. So this is going to be the square root of 16 is 4 root 10. So this is going to be negative 4 plus or minus 4 root 10 divided by 18. These are, 4 doesn't go into 18, but 2 can. So if I were to simplify this, divide everything by 2, I can get negative 2 plus or minus 2 root 10 over 9. And that is those are our two solutions there. Okay. Number 3, if I were to set this equal to 0, I'd have x squared plus 4x minus 13 equals 0. So looking for things that multiply to negative 13, add to 4. 13 is prime, so it's only 13 and 1. That's not going to work. So it's not factorable. So this is definitely going to be a good spot because the lead coefficient is 1, where I can complete the square. Okay, so I'm going to add something in here to complete the square. This equals 13. Okay. So the way we do the completing the square, remember we just take half of the b value and then we square it. So half of 4 is 2. 2 squared is 4. So I'm going to add 4 to both sides. and that makes this factorable as x plus 2 squared. 13 plus 4 is 17. So now I can take the square root of both sides. I can get x plus 2 equals plus or minus the square root of 17. And then we just subtract 2. So x is negative 2 plus or minus the square root of 17. Okay. Number 4, lead coefficient is 1 again. Can we find things that multiply? Oh, no, right, completing the square. Completing the square. Okay. Can we find things that multiply to positive 24 and add to negative 10? What about negative 6 and negative 4? 6, 12, 12 and 24? Yeah. So this factors as x minus 6, x minus 4. So that means my solutions come from where x minus 6 equals 0 and where x minus 4 equals 0. So I have a solution of x equals 6 and x equals 4. Okay. Down here we got now number 5. Okay. Again, there's no linear term. There's only an x squared, which means that I can do this by square rooting. So this gives me x squared equals 7, and then I just take the square root of both sides. Don't forget the plus or minus. So it's plus or minus the square root of 7. And now here, I have a lead coefficient of 2. The middle number is odd. So this might not be easy for completing the square. Let's see if it's factorable. Here, a times c is positive 6. Middle number is negative 7. Things that multiply to 6 add to negative 7, negative 6, and negative 1. So we can solve this by factoring. Now this is the longer factoring here. So it's 2x squared minus, we're going to break up the minus 7 into minus 6 and minus 1. So minus 6x minus 1x. And then we factor this by grouping. So go 2 at a time. These both have a 2x. That leaves you with x minus 3. These, I have x minus 3. This is negative x plus 3. So I need to factor out a negative 1 for those signs to match. So they have the x minus 3 in common, and that leaves me with 2x minus 1. So my solutions come from where x minus 3 equals 0, or 2x minus 1 equals 0. So we have x equals 3 as a solution. We have x equals positive 1/2 as the solution. Okay, so now the more word problem-y parts here. I'll explain how you can solve a quadratic by square rooting. Okay, so the way you can solve something by square rooting is when there is no linear, meaning x to the first power, term. So if you had it in standard form, if you have like the ax squared plus bx plus c equals 0, you would need this middle term to basically not be there. So if that thing was there, okay, so that's one way. Or it could be factored already, okay? Or it's already factored as a perfect square. So for example, if you had the x minus 3 squared equals like 5, okay? Here I can solve this by taking the square root of both sides. This is like the middle step from completing the square, right? So once you end up something here, you solve that by square rooting both sides. So either you just have a normal, boring x squared, there's no x's at all, or it's already kind of factored, so you can take the square root there. So it has to be one of those cases. All right, so explain when it is easy to solve by completing the square. Well, what do you have to do for completing the square? So you have x squared plus something, x, and then this is where you kind of create your own numbers. So there's like a 5 over here. So what do you have to do here? You need to take half of this number and square it, and this has to be a 1, okay? So that means if you have the standard form ax squared plus bx plus c, okay, you would need, or really you don't need, you could deal with fractions, but you don't really love fractions, so you would need this to be 1, and you need b to be even, so that it's easy to cut in half. Now, if b was odd, it still works. If B was like 5, okay, then to complete the square, you would end up with 25/4, because half of that would be 5 over 2. When you square that, it's 25 over 4. So that's not as easy to deal with. So maybe it would still be faster for you to do the quadratic formula at that point, because this always works. It's just a matter of what would make it easy. So to make it the easiest, you really need the lead coefficient to be 1. You want that middle term to be even. Okay. Write the quadratic formula. So sing or hum it when you write it. I know some of the other algebra teachers aren't thrilled about singing the quadratic formula. I love it. It's my favorite song. So you have x. It goes to Pop Goes the Weasel. So x equals negative b plus or minus the square root b squared minus 4ac all over 2a. And you know I'm a great singer because my dogs aren't going ballistic in the background, so I'm clearly not bothering them. So these a, b, and c come from standard form. So it comes from this. You have to make sure you set it equal to 0 first, and then a, b, and c are the coefficients. All right, so use the quadratic formula to help explain how you can determine whether you have one solution, no solutions, or two solutions. So if you have this, x equals negative b plus or minus the square root b squared minus 4ac all over 2a, okay? So if you think about things that could go bizarre here, you have this division. Dividing by 0 is bad. So if a was 0, this would not work. But if a was 0, this wouldn't be quadratic. You wouldn't have an x squared. So we don't really have to worry about that. What we're going to look at is this guy, the square root part. So you have the square root of b squared minus 4ac. Okay? So if this part, b squared minus 4ac, is positive, okay, then when you take the square root, you have this plus or minus part. So you have the plus. So say what was inside the square root was a 9. You would get plus 3 and you get minus 3. So that gives you 2 solutions. If it was equal to 0, okay, then what's the square root of 0? The square root of 0 is 0. And then plus 0 and minus 0 does not actually bring you to 2 different places. Plus 0 and minus 0 do the same thing. So this actually only has one solution. And then the last option is that if this was smaller than 0, okay, then you'd be taking the square root of a negative number, which you know we can't do. So this has no real solutions. Okay? And so this part here actually has a good name. This is called the determinant. Okay, and it is called that because it helps you determine how many solutions you have. Okay? All right. Hope that made sense. I went a little fast at times, but it's a video, so please go back, pause, rewatch, whatever you need, and email if you have any questions. Good luck.